Okay, welcome to the Intro to Civil 3D recording. I wanted to put this together for you all so that you can be able to walk yourself through the introductory level of the program, um, get to know the areas that are involved in Civil 3D, as well as walk you through a sample drawing. So it's going to be a lengthy process, but I wanted to make sure that you got this so that you can start to practice these things. So make sure that you go to your course shell and look for your Intro to Civil 3D module. Um, for this course, it's lecture 6B. Um, I've put in a handout for an Intro to Civil 3D that you can download. I've also included in this module the CAD drawing template that I will show you how to implement into AutoCAD Civil 3D. You can open it in AutoCAD as well. So it's a template that I've created for this course so that you will have all of the layers and all of the title blocks that you'll need for future assignments. You'll also be given a color table file, and I'll show you what that means, as well as a sample map. So all of those are in the module lecture 6B, Intro to Civil 3D, so that you can download that information. So the first portion is the Intro to Civil 3D PDF that I've created for you. Make sure that you read through it at your leisure. You're not going to be tested on anything in regards to what this PDF includes, but it'll give you an overview of what you are expected to be able to, what tasks you're able to complete when you're a civil drafts person. Okay, so it's a lengthy 18-page PDF that I've created for you, along with screenshots so that you can identify where various discussions are located within Civil 3D. Also included in there are tutorials, so you can just click on the link within the PDF and it'll whisk you away into a tutorial so that you can get to know Civil 3D at your fingertips. Alrighty. So I'm not going to walk you through each page of the PDF, but please make sure that you do download that and read through that again at your leisure. All right, so what I want to make sure that you all do is download the CAD drawing template. So when you download the CAD drawing template, it's going to be called D80 template.dwt. Anytime you find a file that ends in DWT, that means it's a template. Anything that ends in a DWG is a drawing file. So a template file is something that we can create in industry, or you can create on your own. And what it essentially does is includes all the layers, line types, colors, blocks, paper space layouts, title blocks, anything that you want to include in a drawing. So anytime you start a new drawing, you already have everything that you need in terms of all of the things that I just listed. So if I'm going to launch into AutoCAD Civil 3D, now again, you may have a newer version than I'm running right now, but for the most part, everything should be exactly the same. If you ever run into something that you can't find that I'm not showing on my version, please contact me as soon as you can so that we can figure out where they've hidden that new location. Okay. So when you start up a new CAD file in Civil 3D, it's basically exactly the same as when you do it in AutoCAD. You can just go to Control N for new. And then here you're going to find the template file that you downloaded. So if I downloaded it to my desktop, which I did not, I'm going to have to find it where I put it. I believe I have it in downloads. There she is. Okay, there she is. So what I recommend is when you download a file, especially for this course, make sure that when you download it, save it to a location that you can always find it. So I'm just going to do a Control-C. I'm going to go to my desktop and I'm going to do a Control-V so that it is always on my desktop so I can easily find it. Okay, you can create a folder, you can do whatever you want. If I'm just going to do examples for this course, I always like to be able to find that on the desktop, and the desktop's the easiest thing to find. So then I can go to that specific file. So here again, I'm going to do Control-N. It says select template. If the file on the bottom, file type on the bottom says DWG, you're not going to find that template file. So you always want to make sure that the file on the type on the bottom is going to say DWT, because that's what it will show. Then if I go to my desktop, there it is, open, and voila, you have everything that you need for this course. So this course doesn't require you to make new title blocks, make new layers, all that stuff. So everything that you ever need for the future assignments will be included in this template. So if we go to model space, we have a nice black screen, okay, and we're ready to go. Okay. Now I'm going to save this file, Control-S. I'm just going to save it as, let's say, D80 Civil 3D lecture, just so that you have that, so that I can upload this file as well onto the course module. All right, so an introduction to Civil 3D, just to give you an overview of where things are located. It's basically the same in terms of command line, all the same, model space, all the same, paper space tabs, all the same, okay? But you'll see that you already have your title blocks and all that you'll ever need, okay? Probably more than you'll ever need for this course, but I built all of these for you just in case you need those in the future, okay? The critical things that are different are all of these tabs on the very top, okay? There's tons of them. You'll use probably 1% for this course, okay? But it's imperative that you kind of go through them and see, see for yourself what exists in Civil 3D and compare it to AutoCAD, okay? For the most part, for this course, you're going to be in your Home tab, okay? The Home tab includes most of the things that you will use for this course. Layers, obviously, how to modify certain things, how to draw certain types of lines, okay? And then here on the left is a feature that is completely probably new to you, tool space. Tool space is specifically for Civil 3D. So if I click tool space allows us to organize the file so that it takes on properties that we want to show up on each drawing exactly the same. So in Civil, we have what we call points. Points are points of information that a surveyor would collect in the field, bring that back into the office. We bring it into Civil 3D and it becomes organized within this points area of the tool space. Point groups, I don't believe we'll have time to go through point groups in this course, but what a point group is basically an organization of various points. So let's say a surveyor went out in the field and they surveyed a street section. So they surveyed, let's say, a curb line and a sidewalk line and a lip of gutter line and a center line and all these different types of features on a street. We may have point groups. So a point group would be perhaps of all of the curb field shots. Okay, a field shot is basically the surveyor taking the instrument, taking a field measurement, and that field measurement is what we call a shot, S-H-O-T. Okay, so those specific shots may be specific for the curve face. Maybe we have another point group that is specific to the back of sidewalk. Maybe we have another point group that is specific to the center line. Why we want to divide points into various point groups? There are various reasons why we would want to divide those things into various point groups. The specific reason for doing point groups when we're doing a survey, a large survey, if we have to go back to the site multiple days, sometimes it's nice to put points into a specific day group. So a point group for day 1, a point group for day 2, so forth and so on. So we can keep track of what we did for each day. Everybody makes mistakes. And so if we had to go out to a specific site and figure out, maybe we had an error in one of our points or our setups, or maybe there was an error that occurred within the instrument, it's better to be able to identify which day we did than have to sift through thousands and thousands and thousands of points. So a point group allows us to minimize how much time we have to take to identify a problem or create an analysis of that specific point group. Okay. So again, in this course, primarily, we're not going to be dealing with point groups, but that's just an overview of what a point group is. Surfaces. Surfaces are used to create contours. So we use our points. We use 3D elevations to create a surface. A surface is a triangulation module that allows us to basically triangulate between points, figure out the elevations between those points, and then it will physically automatically draw a contour surface. Okay. Alignments are what we would use if we were designing roads. So we're not going to be doing that in this course, but if you do work in civil, alignments is something that you will be very familiar with as you progress through your profession. A lot of these things are civil engineering related, so I'm not going to go through those, but you can do pipe networks, you can do all different types of things that are 3D elements. Pipe networks is an interesting thing because it allows a civil engineer to design a pipe network underground and is able to determine whether or not pipes run into one another, so they can figure out, based on slope and based on horizontal and vertical location, they can basically design the whole site with ever having to dig a trench and determine location of pipes. So pipe network is something that a civil engineer definitely dabbles in. Okay. But I'm just going to focus on the top areas here. Okay. We will delve into surfaces later on in this semester, and you will be exposed to points. Okay. So tool space is again where we organize everything to do with this specific drawing. Okay. It's not settings for the entire Civil 3D software. It's specific to this drawing. Okay. You will see, as it says in open drawings, I named the file D80 Civil 3D lecture. So all of these features or all of these components are specific to this specific CAD file. Okay. If you ever need to come back to tool space, it's always in the upper left within your home tab. You can also type tool space. Okay. All right. So we use the drawing template. If you go into your layer manager, you'll see that you have a bunch of different layers already coded in terms of description, line weights, colors, on and off, all that good stuff. So that's already in there for you. Okay. If we were to go into our blocks, you'll see that you'll have a bunch of different types of blocks that are already included in this CAD file. Okay, so you're given everything that you need to complete assignments going forward in this course. Okay, so what we're going to do today is essentially I'm going to walk you through a basic drawing. That was your PDF. Let's download that sample map. So I pulled this from the internet. It's going to give you an overview of how to draw things in terms of a boundary. Okay, so what we're going to do here is I'm going to show you how to use the various commands, whether you're using AutoCAD or Civil3D. So I'm going to show you the AutoCAD way first, and then you'll probably realize that maybe you want to try the Civil3D version. So what we're going to do here is I'm just going to draw the exterior boundary of this map. Okay, now you should be familiar with bearings by now. Okay, you should be familiar with arcs by now. Okay, and if you're not, we can get you there. Okay, you need to let me know if there's certain things that are confusing to you, but we need to be able to use the information that's provided on a map to be able to draw that boundary. Okay, so we're going to be drawing the boundary, and the boundary for this particular map is the bold line on the outside. Okay, so that's what we're going to use for this exercise. Okay, so the first thing when you look at a map is you want to look at the orientation of north. Okay, some maps north is not perfectly straight up and down. For this example, it is. So that's kind of why I chose it. It's from Solano County, so you can definitely download it from the Solano County website, which I'll show you in a couple sessions from now of how to do that. It is free through Solano County, so that's a nice feature from Solano County, is that all the maps that they have for the full county are free to download. So you can, if you live in Solano County and you want to look at the map that's created or that has created the area in which you live, you can download that and draw it. Okay, so if you live in a different county, every county has its own system. Some systems are free and some you have to pay for, so it depends on which county you live in. But everything is accessible if you want to access that. All right, so we're going to work through this particular map, and you can download that from the course module. Now you'll see various components that we're not going to use right now, but you will be exposed to various things coming in the next few weeks. But like I said, we're just going to draw that bold boundary on the outside first. Okay, and so when you're ever looking at a map, number one, again, you're going to look for north and make sure that it's pointing in the north direction. If it's not, let me try to find another map here. Let's see if this one is. So here, this is a different map from a different county. Okay. Oh no, it's City of Fairfield. City of Fairfield, there you go. But north is not pointing directly north. So when you're visualizing how these lines are going to appear in AutoCAD, you have to kind of turn your head to the right and kind of visualize how this would look twisted a little bit counterclockwise. Okay, so but the reason why I chose this example is north is up, so what you draw here is going to look exactly like what you draw in CAD. Okay, so when you're going to draw a boundary, there are two things that you want to look at. You want to look at the center line. Okay, this is a center line. You see Pitt School Road, you see Stratford Avenue, and you see North Lincoln Street. Okay, you see a center line here, and you see a center line here. How do I know that's a center line? Well, it's a center line type. Okay, so if you've taken mechanical, it's exactly the same in civil, center line type. Okay, and you're going to see a CL on there. Okay, typically. Okay, CL means center line. Okay, so you're going to look for that line that surrounds the property, and then you're going to look at your boundary line. Okay, so we're going to use the center line to build the property line. Okay, so first what I want to do is, look through the file, see what they give us. Okay, so what they give us here is we have a center line here, and they give us a bearing and they give us a distance. Okay, right here. Oops, that didn't help. Okay, so right here. Okay, right there. Okay, so what we're going to do is we want to draw a line southeast 0 degrees 10 minutes 0 seconds east, a distance of 508.18 feet. Okay, so if we were to use AutoCAD commands, okay, we would do our line command. Okay, and we would click anywhere on the screen. You want to turn your ortho off so that you have full reign of rotation. Okay, then we're going to do the at command. We specify the distance first, 508.18. Then we do the less than command. Then we type S for south, 0, 0. Okay, D for degrees, 10 minutes, 0, 0 seconds east. Okay, so you need to do the at symbol, the distance, less than, the bearing. Okay, now we can't use the degree symbol in the bearing when we're typing this, so you use the letter D for degrees. Okay, so again, it's going to be at 508.18 less than S 0, 0 D for degrees 10 minutes 0, 0 seconds east. Okay, so then we hit enter and it'll draw our line for us at that specific bearing and bearing and distance. Okay, so you'll notice that when you started a new file, your 0, 0 coordinate is going to be pretty close to that line. What I like to tend to do is move that line way out in space, like for example 10,000 comma 10,000, so I don't have that coordinate right on top of that line. Okay, it's just a preference. Okay, so if I want to make sure that this line is exactly at the bearing that they say on the map, okay, I can do a couple of different things. I can do CG list. CG list allows us to, it's a Civil3D command, so you have to be in Civil3D to be able to use this command. But what it does is if I select the line, it automatically tells me what the course and the distance is. If I'm not using Civil3D, okay, I can use the list command, LI, okay, and it will do the same thing. So list command is an AutoCAD function or an AutoCAD command. CG list is a Civil3D command. Okay, so we have our first line. Okay, and why did I create that instead of just the boundary? Okay, because it gives us specific distances to offset for specific lines. Okay, that'll make sense in just a little bit. So here we come over here and we look at this line. They give us a bearing and they give us a distance. Now, one of the questions a student brought up was, is a northeast bearing the same as a southwest bearing? The answer is yes, if the numbers are the same, okay? Depending on the orientation in which you're going to be walking, depends on the bearing. So if it says north 8950 east, that means I'm starting here and walking to the right. Because if we visualize the north, south, east, and west compass here, okay, this is essentially almost going directly east. Okay, so we would be walking. Let's try to draw this. Tools, comments. Try to draw a line for you. Okay, so if that's our compass, this is north, this is east. If we fall 89 degrees in 50 seconds or 50 minutes, we're almost to here. So that would be the northeast quadrant. Now, if, for example, I'm going to make this large, okay? If we started over here, okay, let's take this and group it. And bring it over. Oops, that didn't work, did it? Let's bring this and this, move that over here. Okay. If this is our north, this is our south, this is our east, and this is our west. Okay. And let's add a little bit up there. Okay. Northeast is the same as southwest. Okay. So if I'm going southwest, okay, this line here is the same. Okay. So northeast or north 89 degrees 50 minutes 0 seconds east is the same as south 89 50 00 west. Okay, so it depends on the direction in which we're walking. If I'm walking from here to the left, it's going to be southwest bearing. If I'm walking from here to here, it's the northeast bearing. Okay, if I'm walking from here to here, it's the northwest bearing. If I'm walking from here to here, it's the southeast bearing. Okay, so what you're going to do is you're going to flip the first letter and you're going to flip the last letter. So if we're walking in the southeast direction, the opposite of that is you change the S to an N and you change the E to a W and vice versa. Excuse me. Okay. Hopefully that makes sense. If it doesn't make sense, just contact me and we can walk through that again. Okay. So what we're going to do here is we want to walk from here to the left. Okay. So we want to walk in the southwesterly direction. So what we're going to do here is we're going to do a line. Okay. O snap to the endpoint there. We're going to do at, and that full distance, 782.41 less than south 89 degrees 50 minutes 00 seconds west. Okay, enter. Okay, so again, if I list that using the AutoCAD command, it tells me my bearing and my distance. If I use the Civil3D command, CG list, same thing. Okay, all right, so we have this line, we have this line. Now I'm going to create that last line and then I'm going to do it in Civil3D or the Civil3D commands. Excuse me. Okay, so here, sometimes maps don't give us everything that we need, okay? But because the map says this is a specific distance off of this line, and here, down here, we have a specific distance off of this line, we have to be able to look at what they're giving us in terms of information and make sense of it. So here it says from here to here is 50.14 feet, okay? And this line here has a bearing of north 000854 west, okay? This here is 42 feet exactly off, okay? it also has the same bearing as 000854 west. Okay, so we can assume that this center line is that same bearing. Okay, so what we're going to do here is we're going to do another line from there, snapping to the end point there. We're going to do at, okay? Now realize that it doesn't give you a distance. Not a big deal, okay? Just put in something and we can fix it later. So we're going to just do 100 less than. Now we're going from here down, so we need southwest, okay? South 03 degrees, 08 minutes, 54 east. Thank you very much. And so we want to make sure that it's correct. South 03 08 54 west, or southeast. Okay, is that correct? Southeast, yes. Okay, so then we hit enter and there we are. Okay, not long enough. Okay, we want to again check it first. CG list, click it. 03. Oops, see, I did it wrong. Okay, so that's why we would like to check things while we're drawing. Okay, so what I'm going to do here is, again, I'm going to do the align command from here, and probably some of you caught that when I was doing that. So we're going to do at 100 less than south 00 degrees 08 minutes 54 seconds east. Okay, that looks better. Okay, CG list. Is that what we did? That's what we did. Looks better. Okay, now it's 100 feet long right now. Okay, maybe we need a lot longer. Okay, so hopefully you know about the command lengthen. Okay, LEN is lengthen command, and so within the lengthen command it gives us 4 different options. Lengthen command allows us to lengthen a line based on 4 options. So delta means change. So if we know that we want to lengthen it at a change of a specific distance, we can do DE for delta and specify the change in distance. P is for percent. So if it was 100 feet long and we want it to be 200 feet long, we could do P for percent and do 200%, and that would make it twice as long. T for total allows us to specify a total distance. So if we wanted it exactly 100.67 feet, we could do T for total 100.67 and it would lengthen it exactly to that distance. Dynamic allows us to just stretch it a specific distance as we wish. So here I'm going to do LEN. I use dynamic all the time, and what it allows me to do then is just stretch it as far as I need to go. Okay, so that's what I'm going to do. Okay, here we don't need a specific distance. It doesn't give us a specific distance on the map, so that's what we're going to use here. Okay, so here what we're going to do here is, now that we have our center line, I'm going to use Civil3D. Okay, for that specific exercise. Okay, so what I'm going to do is I'm going to do the line command in Civil3D. But what we can do here is I can do apostrophe BD, and that allows me to get into a Civil3D function. So I'm going to click anywhere on the screen, and then you're going to see a compass show up. Okay, if I want to draw, for example, this line, remember again, southeast would be going down, so northwest would be going up. So if I click in the northwest quadrant, okay, you'll see when you put your cursor in a various quadrant, it turns red. Okay, so if I'm in this quadrant, I'm in the northeast, southeast, southwest, northwest. Okay, so when I click in that specific quadrant, it locks to that specific quadrant, so I can't get out of that specific quadrant. Okay, so then when I input a specific bearing, it's going to do that for me. Okay, so I'm just going to type 00.1000. Okay, enter. Okay, and then it asks, what is the distance? The distance is 508.18. Enter. Okay, so when I do that, so that is 36. Okay, so when I do that, another way to access that all right, so the way that we can do the Civil 3D version is we can come up to our home tab, okay, create line by bearing, okay, click on the screen. Okay, what we're going to be given is we're going to be given 4 quadrants. Okay, so the 4 quadrants are obviously the northeast, southeast, southwest, northwest. Okay, when we drag our cursor in that specific quadrant, okay, it turns red. Okay, so we're going to select that northwest quadrant. Okay, and now it says specify the bearing. We're going to go 0.1000. Okay, enter. Okay, and then it says specify distance 508.18. Done. Okay, so whenever we're entering things in Civil 3D, if I type EMMSS, when we type things in Civil 3D, we don't have to put the D for degrees, minutes for the minutes tick mark, seconds for the seconds tick mark. We just have to type it degrees, minutes, seconds. So the degrees and the minutes are separated by a decimal. Okay, it has nothing to do with decimal degrees. It's just a way of inserting that specific bearing. Okay, excuse me. So if we did CG list now, list that line. Okay, gives us that correct bearing and distance. Okay, if we need to specify again, I'm going to move that up to here, and I'm going to do this again with this bearing. Okay, so I'm going to come up to here, create line by bearing, O snap to the endpoint there. Okay, now again, northeast is going to the right, so southwest would be going to the left. So I click in the southwest quadrant. Okay, then I specify 89.5000. Okay, again, that is degrees, minutes, seconds, but I don't have to do the D for degrees, the minutes, and the seconds symbols. We're just typing, so it's a little faster. Okay, 89.5000, enter. Distance 782.41, enter. Okay, now you'll notice that if I don't hit escape, it doesn't get out of the command. So then I can go to the next one, and here we're going to go southeast. So I click in the southeast quadrant. Okay, the bearing would be 000854, enter, and the distance we can do 200, whatever. Okay, there we are. Okay, so we hit escape when we want to get out of command, and again, we like to check things before we continue on. So I'm going to check that. Set the right bearing. Yes. Is this the right bearing? Yes. Correct distance. Is this the right bearing? Yes. Okay, so then I can move on. Okay, so that's the command that you're going to use. Okay, you go up to your lines, create by bearing. Okay. Alrighty, so that's the two ways of creating these two lines. If I want to lengthen that thing, I can go lengthen, dynamic, pull it down, whatever distance, and there we are. Okay. All right, so now we're going to build the boundary. Okay. Now, if we want to put this on the right layer, we can do that. We can do DLCL. Okay. And there we are, the centerline layer. Okay. Alrighty, so now what we're going to do is we're going to then build our boundary. Okay, we can see various offsets that they provide. Okay. Now, when I went through a brief lecture on how to add bearings, this is where this applies. Okay, so if we look at north 8950 east, and we look at this bearing south 0010 east, okay, if we add the 10 minutes to this, it becomes 90 degrees. Okay, so again, if let's do this. This is 8950 00. So you can visualize it. And this is 0010. Okay. The 00s add to 0, obviously. The 50 and the 10 add to 1 degree. Okay. So if we were to add these two together, this plus this would equal 90 degrees. So that means this is 90 degrees to this bearing. Okay. What that means is that I can offset this line specifically that distance, and that'll give me that boundary line. Again, here they have that offset exactly the same here. Okay. But what this line here is what they call a tie. So what that means is if we went out in the field and we located this specific monument, okay, a monument again is for this specific map, you're going to look at symbols, and what a symbol represents is you can look at the legend and it's going to tell you exactly what that specific thing is in the middle of the road. Okay, so this symbol with this little circle and a cross on it found 2.5-inch brass disc stamped RCE. RCE means registered civil engineer. This is their license number in a well. So there's it's not a water well, it's an opening within the surface of the street. It'll have a lid on it. Usually it's a brass lid, very heavy. And you can open that up and you would find that specific brass disc. That brass disc would have some sort of what they call a punch. So it has some sort of little divot in it that would allow us to know exactly where the center of that road is. Okay, so they found that. So from that found point, if we walk exactly in this bearing and that distance, we're going to find this point. Okay, that's why we call it a map. So we're finding things that exist out in the real world based on somebody else's findings. So here we have this circle with one line going through it. So they found a 3/4-inch rebar with a tag on it. LS means land surveyor. So the land surveyor's number is 3563, and it's per a different map. Okay, so they're referencing a different map in which they found this specific point. Okay, so if we walked from here to here, it's exactly this distance and this bearing. Okay, so on this map, they say the boundary line, the property line, is exactly 30 feet from that invisible line. Okay, so that invisible line we already drew. So now if I offset this invisible line 30 feet to the left, that is going to be our boundary line. Okay, so I'm going to change that to a boundary line. Okay, so a center line is just like you would see in a mechanical. Center line is the center line type. The boundary line or property line is what we call a phantom line. So a phantom line has a long dash followed by two dashes, short dashes followed by another long dash. Center line is a long dash followed by one short dash followed by another long dash. Okay. All right, so now what we're going to do here is that is 30 feet. Okay, that is 30 feet offset. Okay, so we can look at what we're going to do here now is we're going to look at, okay, so we took this line, we offset it at 30 feet. So that is the corner point, this circle here. Okay, so if I want to draw a circle, let's just make this layer current. I'm just going to put a circle there and just to denote that that's that little circle there. Okay, now what we have here, we have this line, but it's some arbitrary length. We want to lengthen it to a total length that they give us on the map. Okay, so we're going to do LEN. Now here for T for total, specify the length 149.00. You can type 149 or you can type 149.00. It's the same thing. Okay, enter. Now you're going to choose the end of the line that you want to lengthen or shorten. For this case, we want to choose the end here so that it shortens down to here. You can see if I put my cursor here, it would shrink to the north. Okay, so I'm going to click here. And now if I CG list this thing now, it's the same bearing as the center line, and we have that specific distance. Okay. So up to this point, we've just done lines. Okay, we've just done lines. I'm going to copy this thing off into space so I can show you how AutoCAD works and how Civil3D works. Okay, so we're bouncing between the two. We're using Civil3D as the software, but again, in Civil3D, we can use all of the AutoCAD commands and all of the Civil3D commands, but in AutoCAD, we can only use AutoCAD commands. Okay, so here we're going to now we're going to put in curves. Okay, so curves are a little more cumbersome when we're dealing with AutoCAD as opposed to Civil3D, but I'll show you the various differences. Okay, so whenever they have a curve coming off of a line and they don't show anything other than that type of information, we have to assume that it's tangent to the previous line. Okay, so how we draw a curve off of a previous line is we have to use all of the information that they provide. Okay, so the steps for using AutoCAD to create a curve are as follows. Okay, so what I need to do is figure out where the center of this curve falls. Okay, it's going to fall 100 feet off of this line because they have a specified radius of 100. So I'm going to offset this line 100 feet that way. The reason why I go in that direction is because it curves to the left. Okay, if it was curving to the right, I'd offset to the right. Okay, all right, so now what I have to do here is draw a circle from that offsetted line to the beginning of that line. Okay, then what I need to do is draw a line from the end of that line to the end of that line. Okay, now there's a command within AutoCAD called edge mode. By default, when you load AutoCAD or Civil3D, edge mode is set to 0. 0 meaning off, okay? 0 always means off, 1 always means on, okay? When you set edge mode to on or off, it's always going to stay on or off until you change that command, okay? So whether you get out of CAD, you turn your computer off, you turn your computer on, edge mode is still set as you set it, okay? So for edge mode, if your edge mode is off, okay, what an edge mode means is that it's working with the commands of trim and extend, okay? So I have this line here, okay? It travels through this curve, but it doesn't travel through this part of the curve. If I try to do the trim command using that line, it's not going to allow me to trim any part of that circle because this line doesn't physically cut through the whole thing, okay? So when edge mode is off, I can't use any object, or I can't trim any object in which the cutting plane fully goes through that object, okay? If my edge mode is on, 1 meaning on, and I use that line to trim, it allows me to trim off what I don't need, okay? So edge mode on is always a wonderful thing because you don't have to physically draw a construction line so that you can trim something out and then have to delete that construction line. So hopefully that makes sense. Review that part of the recording should you need, okay? So this component I don't need anymore. This component I don't need anymore. So now what I need to do is I need to lengthen this thing an exact angle that it's provided on the map. So if I do LEN, T for total, you'll notice within the command line, I have the option of doing a length, which a length is provided by the map, or an angle. Angle is always more precise than the length, okay? Angle is measured to the nearest 8 decimal places, whereas a length is measured to the nearest 2 decimal places. So we're going to get a more precise drawing if we always use the angle, okay? So I'm going to do A for angle. And now I'm going to specify the angle in which I want this total arc to be, okay? Now remember, I'm using AutoCAD commands, so I have to type it as I would in AutoCAD. So I would do 16D, 45 minutes, 51 seconds, enter. I choose the end of the arc that I want to lengthen or shorten, and there we are, okay? CG list. It gives us the delta, it gives us the radius, it gives us the arc length, okay? Arc length is always rounded to the nearest hundredth, so we're good, okay? All right, so that's the first arc, okay? Now we have a second arc, okay? Now, because there's no other information provided, that's to assume that it's tangent to the previous arc, okay? So the way we do that is here, we're going to draw a line from the end of that arc to the center of that arc, okay? So this goes to the center of the arc. Okay, that was our little wedge. It's a little wedge, okay? So if this is going to be tangent going that way, I need to extend that line this distance, 100 feet. LEN delta, delta meaning change, 100 feet, enter. So then it's going to go in that direction. So you're going to become familiar with lengthen if you weren't already. Okay, so that's going to be the center of the arc that goes in that direction. Okay, so now if I do circle here to there, if we were to list that circle, it has a radius of 100, so we're good. Okay, now we can use this line to trim out what we don't need. Okay, I don't need that line anymore. I don't need that line anymore. And we're going to lengthen it a total angle of 1645.51. LEN, T for total, A for angle, and again we're in AutoCAD, 16D 4551. Enter. Choose the end of the arc that we want to lengthen or shorten. Done. CG list. Are we good? Yes, we can move on. Okay. We can move on. Okay. Now we're going to build it off of here. Okay. So that's how you create the curves using AutoCAD. Now I'm going to come over here and do it in Civil3D. Okay. So for Civil3D, we have a command called curve from end of object. Curve from end of object. Enter. Okay. I'm going to click the end of the line that I want the curve to appear. Okay. And you follow the prompts. So if we're going to the left, okay, if we're going to the left, I have to have a negative radius. That's just how it works. Okay. So for here, it says select entry. I want radius, so I hit enter. And now it says specify radius. I say -100, enter. Okay. And here it says delta. Okay. D for delta, enter. And because we're in a Civil3D command, I can do 16.4551. And again, that is degrees, minutes, and seconds. The degrees and minutes is separated by the period, so it's not a decimal degree setting. It's a degrees, minutes, seconds notation using the decimal. Okay, so because it's easier to type, enter, and now I can create that curve. Okay, again, CG list to check it. Are we good? Yes, we did the same thing in a few less steps. Okay, now what I can do is then create that other curve. Okay, so if we look at let's do this. All right, so what I wanted to show you here is, again, the Civil3D command for the line is located in home. Here, create line by bearing. You could do by azimuth, you could do it all by all different types of things. But we'll just keep it simple, create line by bearing. Okay, and it shows you the step-by-step if you hover over it. Okay, so the curves, okay, if you don't want to have to type that thing, okay, create curve from end of object, create curve, reverse curve, or compound curve. Okay, so if we look at the object or the sample that they provide on this screen, okay, a compound curve means the curves are going in the same direction. Okay, so if we did a polyline, we did a curve like this, and then we had another tighter curve. Okay, these two curves would be a compound curve. Why? Because they share the center of this curve, okay, which is over here, it's on the left, okay, is also on the same side. Okay, so if I had that's the center of this curve, that's the center of this curve. They're both on the same side of the curves. Okay, so it's what we call a compound curve. If we had the center of this curve is here. Let's just put a circle there. And the center of this curve is over here. Okay, so it's a reverse curve because the center points are on opposite sides of each curve. Okay, so for this on our map, it's what we call a reverse curve because it's changing direction. If we were continuing in the same direction as the first curve, it would continue to wrap around to the left. But because it's changing to the right, it's a reverse curve. So if we come up here, create a reverse or compound curve, it's all within one command. Okay. It says you always want to look at the prompt, select arc object. I'm going to choose this. Okay. And now we're going to specify whether it's compound or reverse. For this one, it's reverse, so I can just type R for reverse. Okay. It says specify radius 100. Enter. We're going to do D for delta, always. 16.4551. Enter. Okay. There we are. Okay. So it's the same thing. Okay. It's just different steps with a different program. Okay. So here I'm going to now just continue using Civil3D. Okay. And I'm going to do line by bearing. Choose the end there. Remember, southeast is the same as northwest. I'm going to come here. 0.1000. Enter. 243. Enter. Okay. Now here I can make that curve. So here I'm going to do from end of object. Click the end of the line. Radius. We're going to the left, so it has to be negative. -20. D for delta. 90.0000. Enter. Okay. So now we have this line here. Okay. We're going to do line by bearing here. So what I'm going to do here is I'm going to go southwest because this says northeast. Click in the southwest quadrant. Okay. Can only be within that southwest quadrant. Okay. 89.50. 653.79. Enter. Okay. So now we move down to the next arc. Okay. I'm going to save this thing so we don't lose anything. Now we're going to do create curve from end of object. The only time you use create reverse or compound curve is when we're coming off of another curve. When we're coming off of a line, we're going to use create curve from end of object. Okay. So we're going to click that. Choose the end of the arc or end of the line. Enter for radius. Again, we're going to the left, so it's -20. D for delta, 89.5854. Enter. Okay. All right, so now we're going to do that teeny tiny line. So we're going to come here, create line by bearing, snap to the end. Okay. Northwest is the same as southeast. Okay. 0.0854. Enter. 2703. Enter. Okay. CG list to make sure we're doing everything okay. 0854, 2703, 854, 31. Okay. Okay. So now we have a new line. So I'm going to come here by bearing here. Northeast is the same as southwest. Come here. 3.2604. Enter. 130.27. enter. Okay. Now we have another line here. Okay, northwest is the same as southeast. So I'm going to click in the southeast quadrant, 0.0854, 23.47. Done. Okay. Now I'm going to go in this direction. Okay. Now notice that the dimensions that they provide, you're going to look at what they, what they specify. So here, if you look on the north side of the line, it says 189.55. On the south side of the line, it says 180.43. Okay. And then it has a smaller one at 9.12. So what we do in civil is we always specify the total distance as well as the partial distances located along every single line, so that depending on how somebody is drawing a map, they can always draw it from one end or the other. Okay, so this outside component is going to be from here to here is 180.43. This 3.70 distance is, not to confuse you, but it's specifying a location of a particular easement. Okay, and so we're not going to do easements for this exercise. We're just doing the boundary. So southwest is the same as northeast. So if I click in the northeast quadrant and I type 89.50, 00, 180.43, there we are. Okay. Now we're going to go that full distance. Northwest is the same as southeast. So I click in the southeast quadrant, 0.1000, 269.18, enter. Okay. And now southwest is the same as northeast. So here I go northeast quadrant, 89.50, 530.06. And I should end up pretty darn close to where I began. Okay, so now when I do a distance from the end of the beginning line to the end of the ending line, we're within about 0.02 of a foot. Okay, that's way within tolerance. We want to be within a couple hundredths of a foot when we're doing a closed area. Okay, the reason for that is because if now that I have the boundary drawn, if I filleted this with a radius of 0, fill it with a radius of 0, that means it brings it to an exact point. So then if I was to CG list this last line, it should be within 100th of what it shows here, which it is. And if I list this line, it's within 100th of what it lists here. So we're good. So that's how I walk through drawing the boundary of this specific map. Now, what we're going to do here is we're going to just check to make sure that we're exactly or pretty close to 38.5 feet from the center line, pretty close to 50.14 from the center line on this side, and pretty close to 42. Okay, so if I do a distance, the center line allows us to check to make sure we're in the right spot. So if I do a distance from the end of that curve, perpendicular is always the shortest distance, 38.49 within 100th. Okay, this one we are 50.14. Okay, good. And this one we are 42. Okay, so this is a nice clean map. That's kind of why I chose it, so that you would have something to work on that would actually work. Okay, 9 times out of 10 you'll have a map that actually works. Sometimes you'll find a map that is just junk, and you have to kind of figure out why it's not working, whether they have a typo, or if it's an older map, they've written a number wrong. So that's part of the mystery of creating maps, is sometimes maps are not 100% correct. Okay, so that is the exercise that I'd like you to walk through. You will be having an assignment going forward, using what we've talked about in this session, and then applying it to for this specific map. Okay, it's a little more involved. Okay, but I think you can do it. It includes a lot of line work. Okay, you're just going to be drawing the boundary. It includes curves coming off of straight lines, and it includes reverse curves. Okay, and we'll try to walk you through various things as they arise. Okay, so without further ado, please reach out if you have any questions, and hopefully I can help you going forward. So hopefully this helps. And if you have any questions, please reach out.